Welcome to this video on graphing inequalities. We are to graph the solution set of this inequality. It reads negative 3x subtract 2y is greater than 4. A good first step would be to put this as in the equation of a boundary line. We need to graph the equation of a boundary line, so let's put this in slope-intercept form. Go ahead and hit pause and see how you do at putting this into slope-intercept form as an equality. Welcome back. Let's see if you got the following for your boundary line equation. Y equals negative 3/2 x subtract 2. If you got that for your boundary line, very good. Move on to the next step. You'll be graphing that boundary line. If you didn't, let's go through it in detail and see if we can come up with this. We want to temporarily make this an equation because we want the equation of a line, a boundary line. So I'm just going to put an equal sign in here. Oops. Let's see if I can clean that up a little bit there. Subtract 2y, and we're going to temporarily put an equals 4 in there. And we want to solve for y. To put it in slope-intercept form, we want the y all by itself on one side. So we'll need to add 3x to both sides of our equal sign here. So we'll add 3x on this side and 3x on the right side. The x's cancel out on the left side. We're left with a negative 2y. And let's write our variable part first here. So that'll be 3x. And then there's understood to be a plus in front of that 4. So it's 3x plus 4. Next we'll divide everything by negative 2. Dividing this by negative 2 here, and negative 2 out here, the second term on the right, and we end up with a positive 1y equals negative 3/2 x, and 4 divided by negative 2, what's that? That's minus 2. Okay, so we get this for our equation of the boundary line. The next step is to graph the boundary line. So if you have an idea of how to graph the boundary line, go ahead and put it on pause, and we'll come back and we'll check your answer. Okay, welcome back. I believe the boundary line should look something like this. You should have a y-axis and an x-axis, hopefully a little straighter than mine, but let's make that our y-axis and our x-axis. And you probably will have a point probably down there at negative 2. That's 0, negative 2. And you might have another point, let's see, down 3 from there. And over 2 from there. You probably have another point out here, say about, not about, but maybe exactly at 2, negative 5, right here. And you should have a dashed line going through those 2 points, and that is your boundary line. If you got that, go ahead and move on to the third and final part where you will be shading either 1/2 region either above or below that boundary line. If you didn't get this for your boundary line, let's go through it in a little more detail. Okay, so first off, let me change to a different color here. First off, when it's in slope-intercept form, the first thing to do is take this part right out here. This is the y-intercept. And that'll tell us where our line will cross the y-axis. And it crosses down here 2 units below the origin. So that would be right down here at 0, -2. So 0, -2 is on our boundary line. And from that we can use this part out here that's the coefficient of the x term. That'll tell us the slope, and that'll help us get a second point. The slope is -3/2, and what that means is from any point, and we do have a point, if we rise a -3, well, that just means go down 3. So if I go down 3 units, I'll now be down here at, let's see, I was down at -2, 3 more units, I'll be down to -5 down here. And run +2. It's always, I always think of the running as being always positive. So I'm going to run across 2 units to the right. 1, 2, and I'll get my second point. And that point in this case is at 2, -5. And once I have 2 points, I could graph other points on here, but once I have 2 points, I can go ahead and join those together. And then the decision is whether I should join them with a dashed line or a solid line. In this case, it's going to be a dashed line because we have an inequality here without an equal sign underneath it. If it was a greater than or equal to sign like this, or less than or equal to sign, it would be a solid line. But if it's just either greater or less, it will be a dashed line. So in our case, we wanted a dashed line. And that's what we've got. Okay, so for the third and final step, we need to shade one side of the boundary line or the other side, either this half plane up here or the half plane on the other side. And how we determine that is we need to pick a test point. Any point that's not on our boundary line is a good test point. We could pick any point. It's common to pick the origin if it's available. And it's available here because our boundary line doesn't go through it. So let's pick the point 0, 0. The reason why it's picked so often as a test point is it makes the math very easy. So in our case, there's our original equation. Let me just write it down again right here. -3x, or not an equation, it's an inequality. -3x minus 2y is greater than 4. And we want to just plug into that original inequality 0 for x and 0 for y. And see if we get a true statement or a false statement. So we'll just replace the x with 0, replace the y with 0, and see if we get a true statement or a false statement. We get this -3 times 0 is 0, minus 2 times 0, that's also 0. 0 is greater than 4. Is 0 greater than 4? No, it is not. So our test point is not in the region that we want. It's not in the half plane that makes this true. So we want to shade the opposite side of the boundary line. We want to shade down here and not shade over our test point. And there you have the solution. I hope that helps. We'll see you next time.